So for each of the following cases, identify the order with respect to the reactant. So case A, we have this is actually really, order 1. The half-life of A decreases as the initial concentration of A decreases. So half-life of A decreases as the initial concentration decreases. B here says a twofold increase in initial concentration leads to 4 times the rate. C, this is a twofold, or a 2 times increase of concentration leads to a 1.41 increase in rate. And 4, this is D, the time required for A to decrease from A0 to A02 is equal to the time required for A to decrease from A0 to 4.5. Rate of decrease of A is constant. Increase of A is constant. So let's look at the first statement here. It's asking us which of these ones are we want the order of the reactants, right? And we know that the order here, rate equals K times A here. So we have K, which is some type of rate constant, and we have A, which is the concentration of our reactants to the power of their coefficients. So this here is going to be the order, and we write X here. This here is going to be the overall order of our reaction. So it says here the half-life of A decreases as the initial concentration decreases. So I'm decreasing A here. So A here is our initial concentration. And it says here as the half-life of A is going to decrease as concentration also decreases here. So we're looking at we're looking at basically the concentration, which is given as A here, and then we're looking at the half-life of A is also decreasing as well. So let me just find you the formula for the half-life here, because I don't know it off the top of my head. So half-life of a reaction formula. Again, you should be given these formulas at the test anyways, so I don't bother to memorize them as well. So we have half-life, which is T half, is given as the initial concentration over 2K. And this one would be, this here it would be a, this one would be a 0 order. So the half-life of A decreases as the initial concentration decreases. So this in this one here, if we follow this kind of reaction here, this one would be a 0 order. So A here is a 0 order, because if we decrease our initial concentration in this guy, our half-life is also going to decrease as well. So in this case here, this will be a 0 order, and this is here is a 0 order, 0 order for our half-life. This is the formula for the 0 order, which is good. Says here B, a twofold increase in the initial concentration leads to the rate of 4x, right? So if I'm increasing this by 2, what is my rate going to be? It's going to be 4 times. So I can put 4 here as the rate times K of A, and this here would be a x here, right? And oh, and I'm increasing the total concentration by 2. So this would be a 2a to the power of x. So what's x here? Well, x is simply just 2 to the power of x equals 4, right? And that will give us 2, because square root of 4 is 2. So this here is going to be the second order, which is correct here. So this is the second order. C here is a 2x increase of concentration leads to a 1.41 increase of rate. You could also visualize 1.41 as the square root of 2 here. I believe that's the square root of 2. Let me just check that for you. Yeah. So you can think of it as 1.41 is root 2 here, increase in rate, times k times, this is 2a to the power of x here, which means I'm going to have 2 to the power of x, which equals 2. Or you can write root 2 as half here, which means x here has to be equal to half. So this here is going to be a half order. And then finally, for 4, it says the time required for a to decrease from a0 to a0, half of that is equal to the time required for a to decrease from half to 0.4.5. The rate of decrease is constant. If the rate of decrease is constant, then the concentration here does not even matter in the first place. So if I'm decreasing this and it's not affecting the rate here is going to be the same, then this has to be in the 0th order. So rate only depends on your constant here. So this here says, this is the big giveaway. The rate of decrease of a is a constant. So this here is the constant k, which means the order here, x is going to be 0, the 0th order. So the solution here is correct.